All right, so what I want to talk today is a very basic thing, okay, about version control, specifically how do we use Git. Okay, so this lecture was created from the very first time we taught software engineering back in 2014 and for undergrad 2015. So it's about 10 years since then, okay, and over the past 5 years, I literally didn't give this lecture anymore because I have a recording. I've been using that all the time. Because I think today when we talk about Git, it's quite different from 10 years ago. 10 years ago, most of our students do not know version control, and most students never used Git before. When I was asking, only maybe 30% of students actually have ever used Git. But today I don't need to ask you, everyone has used this one before. Okay, so it's very different. But I saw that, maybe come back again to re-go through this content, especially some of the background information. And also, I do want to highlight some of the most practical aspect you need to know. I do feel that this one is very important because if we're going to talk more about using AI and generative AI to build software or software engineering in generative AI, Git is so important. One reason is that you really need to have all this major check-in to the Git repository as a kind of a safe backup because you never know when the AI will do something wrong, mess up your code base. I think use Git properly is actually more significant than before in the context of generative AI. Okay, so I want to go through things really quickly today, and I want to speed up things. Most of the things you should already know, even something you don't know, that's fine. You just need to come back and then do those practice yourself. I just want to cover the most important things in my opinion. So Git is a tool, something we call as version control. Okay. The reason we need a version control pretty straightforward. Okay. One reason is that we want to have a backup. And this is actually really important. I don't know if you guys have this experience before. When I was young, when we were writing the code, obviously we don't have version control, or there were version control, but when I was like I was writing my code in elementary school, middle school, even college. Okay, that was back in late 90s, 2000, early 2000. I mean, there are version control tools, but nobody's gonna teach me about version control. Okay, so that's something you only would need to use in the companies. I was very young, so I didn't know that. But I wrote code, right? So I don't know if you ever had this experience. Every time you wrote something, you wrote a lot of things, and finally it's working. And then in order to save it, you just worry about, this thing being broken. What I would do at that time, I would just make a copy of the file and then put it on a different folder. And then I keep working. And I started producing more and more copies. Every copy I'm gonna name the file with a date so that you know which one is earlier, which one is later. And then sometime when once we have internet, I started sending that file as a, attachment to just save it in my email inbox so that's safer, right? Instead of just local computer. So that's a very common practice. Some people probably had that kind of experience before of keeping track of your code to be safe, make copies. So obviously version control tools like Git can also do the same thing. That's one major purpose. The second one, more importantly, is that the version control tool allows us to collaborate. We can work on the same repository at the same time. And here is the case. So if you look at we have a code repository. Okay, two developers are trying to work on that. You have Bob and Alice. Okay, so they both make a copy. They start to make the changes, and obviously they're gonna build two different kind of changes. Okay, now what they need to do right now is push the changes back to the repository because the repository is a centralized repository everyone should use. So Bob wrote the change back to here. Okay, so Bob finished it first. And then after that, Alice wrote her changes back to the repository updated. Okay. Clearly, if you follow this one, you can see there's a problem because um, they both got the same copy. They made different changes because one happened after another. So when Alice change wrote back, that change is going to override the change Bob made. So this report is only going to have the changes from Alice, nothing from Bob, right? So obviously this is not good. Okay, because if you don't manage the versions, if you don't enable the collaboration, things like this will happen. Okay, so we can't let this happen because there's gonna be a lot of collaboration going on. You don't want to afford of missing all the changes. So one of the solution is called the log modify and unlock solution. So I'll just go through this really quickly. The centralized repository, same thing. We make a copy. Whenever you want to make a copy, you want to grab a lock. If you guys have learned operating system course, you probably heard about this concept about lock. Anytime you use a resource, if the resource is critical, if the resource cannot be easily shared, you want to lock it first and make sure you have the permission to own it, to make the changes. And then once you're done with the change, you unlock it, you release the lock, right? The same mechanism. So you need to grab the lock, and obviously you have to check that this repository is not locked yet. If that's the case, you get the lock, you lock it, and then you read the copy, you change. And this time, if somebody else want to grab the lock and want to also make a change, you can't do that because the repository has been locked. You cannot do this. So all you need to do is wait until someone else finish that change, and then that's going to unlock the repository. And now the second person can come in to grab the lock, and it looks like the repository is not locked. So that's perfect. We can set a lock, and we get a copy. We work on a change, and after that, we roll the change back. Okay, so the lock mechanism helps solve the problem. Okay, but here's the question, guys. If you understand this one, do you see any issues with this problem? What's wrong with? If you do this kind of a lock, okay, what's wrong with it? Yes, Carl, please.
Um, Only one person is going to be able to edit it at a time.
Exactly, exactly. Because the rest of us had to wait until it's finished, until it's locked. So this one, if you say, oh, I have like three other member team, they're very slack. They don't do things. I don't think this is gonna be a problem. That I might be agree. Okay, but in reality, in the professional coding environment, okay, I'll give you one example. I know the biggest team. So back in 2012, I had a dinner party with a friend who works in Microsoft at that time. At that time, the guy he was working in the Windows team, okay, probably the biggest team in Microsoft. And he told me that so he was working. I was asking, okay, which team you were in, and then he said, well, I was in the Windows kernel team. Just think about writing the kernel of the operating system, which is a pretty critical team. I thought, well, that's very cool, very impressive. And I was asking, so how many people are working on Windows? And I don't know what number you guys can guess. Okay, for the whole Windows team, the developers, just estimate. And back in 2012, he said there are over 5,000 developers working on Windows product. 5,000, mostly developers. Okay, so that was the scale. Obviously, when you have that kind of large team, you're managing the same code base. This is obviously not going to work. Okay, so we need a better, more efficient solution. So the copy, modify, merge solution is basically what we use today. So repository, and then you want to make changes, that's fine. Just get a copy, don't do the log because that's not going to work, right? So you read all of those, and then you start to make changes. And then one of them finish it, okay? They actually write the change back, okay? Sorry, I think the two images were swapped. And then you read the change back, and when the other person finish his changes and he's trying to read change back, but at that time he need to compare the version because there has to be a way to telling the second developer, now you see the current repository version is different from the version you actually used before when you did the copy. If that's the case, the repository need to reject that change because that's not safe, because very likely you're going to override other changes. So what you do now is that you actually have to reload that new changes back to your repository, and then you merge the changes. Okay, you basically have to produce a new change because now the version is different. If that one is finished, you write it back, and finally, everyone will have the same version. Okay, so the difference between this project and the previous one is that we don't set locks. We want everyone to copy the code base anytime you want. But when you are pushing back the changes, you have to compare the version. If that version is different from the version you are in, then please get updates, merge them, reprocess them, and then send it back. Okay. So we basically delegated some of the responsibility back to the developer to verify the versions, but that actually enables bigger and better collaboration. So that's approach most of the tools using today. All right. So that's why you need a dedicated tool to manage this one. A version control tool is not just for backup, for safety, but also for collaboration. And also because of some of the tools like GitHub, right? So GitHub is a platform and they use Git, but they track all the different things. So using all the tools to check in code allows you to manage all your progress, see the matrix and everything. That also is a very good way to manage the whole software engineering process. Okay, so these are the main features or functions we need version control. But why specifically we learn Git? Today, if I ask you version control, probably Git is the only thing you know. Okay, I don't know what other tools you ever used or heard. But I'll tell you, when I was in grad school in 2007, when the first of the professor who taught me about version control, we didn't have Git. At that time, there were some of the tools very popular. One of the most popular one is something called SVN. You can still probably find it.
Yeah.
There is a tool called CVS. Um, there is a tool called Totters. And then Amazon at that time called used something called P4. I remember that's what it's called. And then Microsoft used something called um, Code Force or Code Forge. I can't remember. Yeah, it's been a while. They all use totally different tools. Okay. So Git was really a very new and young tool. But then now it's just basically there's no second thing. Nobody uses anything else. Okay, a little bit history here is that they obviously they have very good performance. You have GitHub, everything make it very popular, big company are using it. But the reason behind it, why everyone using it, well, you have to look at the history because you want to understand who created this tool. So the history actually go to the system called Linux. It's a big open source project. You can still find the Linux code. It's open source and free. You guys can always download Linux code to build your own operating system. When they were building this large open source project for Linux, they were initially using a tool called a BitKeeper. Okay, this is one of the version control tools. I think there was nothing really totally wrong with it until one day that they started to ask for some kind of a licensing. Basically, they wanted to pay for it. I think that's kind of the short story. Okay. But then, this is the project. It's a very large scale. Many developers are using it, and obviously that's going to trigger a lot of cost. Maybe there are other reasons, but obviously the people who are using it used to be free, but now they have to pay for it, and they don't like it. Okay, they got to piss off. Okay, so one of the most important author of Linux, okay, this guy, he just said, well, I want to, manage all my project. Okay, so I would just write it my own. Okay, you don't want to use us to use this one for free. Well, I'm gonna write my own too. So after he actually created Linux, not after, okay, it was after a long time, and then he is was the one that who created Git. See, so this is very often referred as one of the top 10 greatest programmer, and just because he did such a good project. Okay, Linux is such a complicated system, operating system, and now Git is just another one. All right, so popular. That's a little bit of history, but at the same time, you can see if a Git can manage a system like Linux, that kind of scale, it will work for any other software. Okay, because Linux is pretty much just like Windows. So many people are contributing, and it's very complicated. Okay. As you use Git, I know a lot of you probably use GitHub Desktop, which is a pretty good tool. Okay. But for CS major, I highly suggest you need to master the command line. Okay. The command line, because normally the graphical UI is limited, sometimes error prone, but not necessarily the case for GitHub. The GitHub Desktop, they did a pretty good job that they can do most of the things pretty nicely, smoothly, not too much issues. But then too, before Git, a lot of other tools, I had a lot of bad experience with those. Okay, so command line is normally a safer way, but more importantly, if you can do things with command line, then you can build scripts. If you have a script, that means you can easily automate a lot of things. You can write scripts, automate checking certain things to check out certain things to synchronize. Or sometimes the graphic client is not available. If you're working on the terminal, you just cannot use the client. I also want one more bullet today that if you ever use some of the generative AI tools like Cursor or Cloud Code, they can run command line too very easily, but they cannot run the desktop versions easily, right? So if they can run the command line easily, then if you use the command line to the checking code, then that means they can automate a lot of things for you. Okay, so that's just another advantage. So for the CS major, I highly recommend everyone should pick up, the command line to do it. All right. So the main things I want you to master, there are about 5 or 6 different sections. I'll demo and show this really quickly, just for the recording purposes. But a lot of things you already know, then pass it. If you don't know it, you should try it. Okay. You will actually need to use a lot of this one later on along your project and assignments. Okay. So number one, how do we start a repository? How do we start a folder? Using Git, there are normally two approaches. Okay. One approach is there is a repository being built and you have the permission. You can download, you can get that repository, make a copy. Okay. So the way it works for Git is that you often have this remote repository, which is a centralized repository. So that's the most authentic copy of the whole project. And as you are a new developer or someone who want to contribute to that project, you have to make a copy first, a local copy. You can never write directly on a remote copy. Okay. You always need to make a local copy. But then the key here is that that local copy you're getting is exactly the same as a remote copy. In the old days, a lot of version control tools, because the size of the repository was huge, you're not getting the whole part of the repository. You're only getting the things you need. But the Git want you to make a complete copy. Even though there might be a cost in terms of space, but it gave you a full advantage of, just dealing with everything locally very fast. You don't have to come back to the remote project unless you have things done. So that's the maximum. So that's why they have a command called a git clone. If there is a repository being set it up, you can just clone it, download it, and copy it, right? So this one, I just want to show it very quick. So I just opened one of the older software engineering project. We use Java to write this one. This one is already there. So what I will do is I go to the repository. I need to find that address, which is this one. Okay. And then I find the address and same for the other project. You just need to get the git repository address. Go to your terminal. Okay. Go to the folder you want to work on this one. And I'll go to CS4800 and yeah, there is no this project. Okay, so what I do is do git clone, and then I just copy that URL. And basically, what they do is they just download the code and to my local machine and copy everything. They just did a complete copy. So now if you look at my folder here, it's called a demo web project, and that one has exactly the same thing as the other repository in the browser right here. Okay, so all the file, they have README file. I just want to see the README file. That's the same thing as here. Okay, so this command is called git clone. Okay, a lot of you should already know it. Okay, remember, you just need to go to the repository, click on code, and then copy the address and do the git clone. Obviously, you can download zip, but you should know that's not a CS major to do. Okay, so if you've never done CS, you don't know software engineering, you can download code, you get the same code, but that's different. You're not connected with the repository, you cannot push things back. Okay, you always do the git clone. So that's one case that you have an existing project, then you just want to help and then contribute, you make a copy by doing git clone. Okay, that's approach one. Another case is that you're starting something from scratch. There's no repository, and then you create something locally, you test it, and then you want to create a Git repository for it. So that process is called Git initialize, right? So here, going back to the project we did last time, this was the budget lunch example, right? So I'm going to run this one, make sure this one is still working. I have both the front and back end done. This is the budget lunch project, and I search for $10 and you can get all the results. Very nice UI, everything. We use the AI to help us. So the code is there, a lot of code being done. I want to create a repository for this and push that to the GitHub, right? In order to do this, well, first of all, in the GitHub, you need to create a repository. In other words, GitHub serves as a kind of a host, right? A server that can save all this code into the cloud environment. So I go to the repository here, I do a new repository, and now I'll call this budget lunch app, web app. All right. I'll leave everything here default and I'll make it public. All right, because this one is empty repository, nothing is there. So you can feel free to push your changes to there. And then the nice thing is that they actually give you some of the command to teach you how to do this. Okay, but we will actually follow this one here. Okay, I'm gonna do a initialize and we're gonna add everything. We're gonna commit everything. Yeah. So the other one, my guess is that the other one, okay, so we'll explore that later. Okay, so the other one here, because I was doing something very simple, just checking everything, and then this one has tons of like files and build files which we shouldn't check in there. So I think because the number of files, size, and everything, I think they rejected. Anyway, so we'll come back to this one later. Okay, so let me just show you the other project that um here, and we can come back to fix that issue. How do we ignore certain things? Okay, so the ones I use was this friend-end project, this one. Okay, we just use this one. Okay, very simple, like a friend-end page that we wrote for some testing purposes. So right now, as you can see, we already pushed everything to GitHub. But back to the topic here, what we were trying to discuss is to introduce the other way where you don't have an existing repository and you have your local file folder, you want to turn that into a repository, you do the git initialize. Okay. So the ones I showed you from GitHub, those list of commands, that's something they suggest for you to load something to the GitHub so you can always follow that. Okay. So anyway, the first section here, I just want to mention the two ways of building and working with a get a local copy, either clone or initialize it. All right. And then once you have it, the most important thing you need to do is how do you push and adding new changes. Okay. So the way Git works here is that they follow different steps. So you have a working directory and you need to add certain things to they call it staging area. And from there, you commit to the local repository and finally you push to the remote repository. So go through the whole process. The main goal is to make sure that you do things very carefully. You manage the changes. You know which one you want to push, which one you don't want to push. You also want to tell Git certain files are important to track and certain files are not important to track. So you have to explicitly tell Git which one to track, which one to not. So that's the purpose of a staging area. So you have all the copies. You add some new things. And you need to tell Git, first of all, I did some changes with new file, new code. Please add that to the staging area. These are the changes I want you to remember to record. Okay. And then you keep making changes. Once your change is done, you think you finish it, and then you do a commit. You want to commit the whole changes. But this time the commit only commit to the local repository. It's like Bob and Alice example. You finish the change. And once you're really sure you want to go to the remote repository, you do git push. Okay, so let me show you. Very simple. We'll go to the terminal, sorry, the editor. I want to add some more food, right? So I want to add another one and then just more. Okay, so AI helps us generate. So I made a bunch of changes. And now I go back to my terminal. Okay, there's a one command called git status. Okay, so this one you really want to use. Okay, get status. Anytime you're not sure what's going on, use get status because that tells you the status. Right now you're using the main branch. You are modifying this code, and you can see it said that the changes not staged for commit. So they know you made changes, but Git is not sure if you want to track those. So what I do is git add. I want to add that file. All right, I will tell Git that well, this is the change I want you to track and record. So now if you do Git status again, you can see changes to be committed. So the color changed, and then the Git knows that you actually later on want to commit the change, want the Git to manage the change. So that's called a staging area. And once I'm done, I do git commit. Okay. Once you do the commit, the Git asks you to explain what kind of change you're making. This is so important for software engineering. Anytime when you make a change, you explain the purpose. So the rest of us can see the change and understand what we're trying to do. I'm saying that new food items have been added. All right. I'm going to save this one. Now I finished the commit. And now the changes has gone to this area, to the local repository. I finished that change. So I go to git status. As you can see, it says your branch is ahead of the main branch by one commit. Okay, by one commit. That means my changes ahead of the remote repository because the remote repository doesn't have the change yet. Okay, so what we need to do is to do the git push. Okay, we do git push. And this process, you can see that's connecting to the remote server. It takes some time, but it sends the changes back to the server. So now I go back here, I refresh the page. As you can see, there's a second page, second commit here, and there's 1 minute ago, there was a new change. And if you look at the code here, these are the new things I just added to my code base. So this whole process actually allows you to make a change from local all the way to the server. Okay. So let me repeat that again. All right, so I'm gonna add more. We just add more. Okay, so this AI thing is so easy. Okay, so we'll just add more changes. I save the code, go back, git status, git add, git commit. And if you don't want to do the terminal, you can do the message here. Added more items, git push. Just three command, add, commit, and push. And then you go back here, you refresh, and then you can see the changes are pushed to the repository. In the repository, you can always open the commit history right here. You can see what's being changed. That's the commit message you wrote. That's why this is so important. By reading this one, you understand what people are doing, and then you can click on it when they change. You can see exactly what has been made in terms of the changes. Okay, so that's what the tool gives you. So that is how you make new changes. Okay, so this step is probably the thing that you use most. Most of you already know this one, so that's why I just want to show this one quickly, save this recording as a record so you can come back to check it. Some of the things here very important. I explained the git status. So that is your friend. Okay, always use that status to check what's going on. And this means everything is clean, nothing to change. And otherwise, you can see some of the static changes. So status is very important. It's your friend. The second important command is called git log. Okay. So as you can see, this one shows you log history of all the commits happening. As you can see, these are the same ones that you can see from here. So the history of all the commits. This is very helpful. You can see which one has been pushed, which one has not, where you are right now, what's the original version, what's the remote version, and a lot of information. It's called a git log. You're also going to use branches. We'll talk about branches later, but you can see branches basically is another kind of copy in your local. You can do, you can manage different versions. Right now it's a main branch, so you can see you are at the main branch. Sometimes the code base will have different branches. So this command allows you to check status. Okay, we'll come back to the branch a little bit shortly. And the most difficult one when using Git is to synchronize a change. So that's what we explained earlier in Bob and Alice example. You can see this example is pretty sophisticated. So two people are making changes. They both get a copy. One finished early. The other one try to push, and you cannot push it because the version is different. So that's how you need to make some modifications or merging. Okay. So now let me show you the example. I'm going to show you two terminals. Okay. So this is the workspace. I'm going to create a new folder called Alice folder. So I go to Alice. So this is a different folder. Okay. So for example, now Alice also want to work on this project. I go to here. I do git clone. Okay. I get this copy. So Alice folder also has this project called a budget lunch web app. Okay. So now this is Bob's uh, version, and I can use the IDE to open Alice folder. Okay, so this is in PyCharm. Okay, different. And then they just assume these are two developers. Okay, they both start to make changes. So I'm going to start with Alice. Alice said, I don't want all this, junk food. I'm going to delete some of those. Okay, I want to keep the healthier version. Okay, all right, I delete some of the changes. Okay, so let's go back here. I do get status. See, you made some changes. Okay, you changed the index HTML file. That's exactly what we did here. And they also found some of the changes new. This .idea, that's the file from PyCharm. So the PyCharm IDE got some of the configuration files it's generated. So Git realized that this is called untracked files because we never seen this before. So I'm not sure if you want to track or staging this. So you can add them or not. So that's the purpose of git add. So in this case, I don't care about this one. I only care about this. So I'll do git add index. Okay. I do git commit, remove the unhealthy items. And I do git push. All right, push it successfully. So I go back here and as you can see, this time some of the item has been removed. If you want to see the latest change right here, and that's the change being made. Okay, so let's keep doing this one. All right, so Alice want to do more things. So go back here. So this time we are gonna do maybe just do adding this one called a peak coffee and just finish the name Panda Express. And I'm gonna change some of the order. I like healthier, so I put healthier here. Okay, so that's a change. So we'll do get status. All right, and then get add. I'll do it one more time. And now we'll do get commit, making it more healthy. Okay, and get push. As you can see, this developer is constantly making the changes. All right. So if I come here, okay, first of all, there's a simple case that if I heard, well, I heard this new guy actually came in, made a lot of changes. Now, go back to take a look at Bob's folder. It's still the old version, okay? So we need to synchronize this one to load the changes. For example, Alice is sitting next to you, and then she said, "Well, I got a new change. You better actually pick it up, because this version is not the same. If you know that, you should do it. Okay, so how do you synchronize that? Well, you use some command. So you do something called a git put dash dash rebase. Okay, I'm not going to explain what the rebase means because I actually don't know that. But I'll tell you this is the best way to sync up the project. You can also do git pull, but I would suggest you do git pull that rebase. You can go to ChatGPT to find out what that means, but it's preferred. Okay, that's what the Amazon told me to do it. So let's see what happened. Okay, so right now this is Bob server, doesn't have a new version. So I do git pull dash rebase. All right, so see this one, they load a lot of changes. I go back to my server here. Everything gonna be changed. This is the peak coffee, Subway become first. I don't have McDonald's or Burger King anymore. So now both Alice and Bob had the same version. Okay, so this is a simple case, guys, because I had a version, I didn't make any changes, and I just reload the change. I synchronize. So now I have the same version. Okay, let's keep doing this one. All right, so let's see. Alice is very aggressive. Okay, he said, "Well, I don't want to do any of those bad junk food. Okay, pizza not good. Okay, to not have, and Wendy's also bad. Okay, and I want to add maybe something even better. So I don't know what is the better things. Okay, just maybe just Diet Coke. Okay, all right. So some more changes are being made. Get status, get add, get commit, more stuff, get a push. All right, so Alice now finished the change. But this time, Bob doesn't know the change is being made. And Bob started to do, oh, come on, this is not very interesting, not very good, like lunch menu. I want to add something more fun. Okay, I'll do and then in and out. Okay, all right. I will do like what else? Like we have a central point, right? Or a buffet place. For Starbucks, I want to be, or I don't like a peak. Okay, I like what else? Like um, CPB coffee. Okay, I want to make a lot of changes here, and um, yeah, I'll do that change. So now this is the situation. All right, so remember, let me recap. Alice finished all the changes. Right now, this is Alice version, Diet Coke. And then here, if you go back, refresh the code here, the repository has added changes. You see Diet Coke, peak coffee, and everything. But um, now the Bob is done with his changes. Okay, get status. And if you want to see the changes, you can do the command called get difference, and you can see the file. And see, that's the change we made. We changed the peak coffee. We add some more items. So we add the orders here. So we also made some changes. Okay, now I'm done. I want to push it. I want to do git add, get put commit, modify the menu, and then let's see what's going to happen. I do git push. Okay, remember, this is a case where I'm going to push something, but that server version has already been updated by one. Okay, so I do get push, and now some error happens. Rejected. See, rejected because the version they saw that the Bob was working different from the version currently has. And failed to push some of the changes to here. Updates were rejected because remote contains work that you do not have locally. This is usually caused by another repository pushing to the same reference. If you want to integrate remote changes, you have to get a pool and all this. That's the situation. All right. So the solution is that we need to make sure that you reload all the changes. You get the new version, and also based on that, you had to modify and merge your changes, do a little bit extra work. Okay. So how do we do that? Well, we use that command. So git pull rebase because we need to get the latest changes. All right. And then this time, well, it's a little bit better case because it automatically merge all the changes for us because they figure out, okay, we change this one, we add this, and then we this that changes, and then so the two automatically merge all the changes. We didn't have to do the merging. Okay, so this is good. And then if that's the case, you do git status, okay, and then since you merge all the changes, you can do git a push. Okay, and now this one has uh, the version correctly. Okay, so but then this one is lucky because that rebase process automatically turned did all the changes. Okay, so let's find a case that's pretty bad. Like you both did something that you had to decide which one to use. Okay, let me do this one more time. So for example, let me resync up this one here. Okay, now Alice also had to change. Let's make sure we do this over one more time. Okay, now this time, okay, let's both change something. Alice want to say, I want to do a Starbucks, um, you know, latte. All right, let me make sure that we can see this one here. Yeah, I will do git add, git commit, git push. Alice always finish it first. Now Bob says, I always want to do this. I want to do a Starbucks Americano. Okay, so I go back here, I do git add, git commit, and git push. Same error because someone else sent a post, a push. You have to sync up. So I do git pull dash rebase. All right, so this time a little bit tricky because they detect there's a conflict because you both are trying to change the same thing. And I cannot easily just let you to override it, even though you're trying to synchronize change. So what you need to do is that you have to manually resolve all the conflicts. So you guys decide which one you want to use. So I go back to the code that you can see now the code got to change a little bit. It actually says in the head, currently the remote has a version called Starbucks Latte. And now you are trying to change to Americano. And then which one you want to use. So the machine cannot decide it for you because that's your responsibility. And then I look at this one, I said, well, no, I need to use Americano. That is not healthy. Okay, so since you want healthy, I want to keep you healthy. So I need to manually clear all of this, okay, to make sure I resolve this one. I save the code. After that, what I do is I do git add this file back. I do git rebase dash dash continue. All this command I have listed here. Okay, so but you don't really need my slide. You can just use ChatGPT to get the command. All right, and then I save the message. I do get a push. All right, so after all of these steps, now you go back here. That's the change I have. Okay, so as a person who pushed the code secondly, I have to resolve the changes or the conflicts if there is a conflict. Okay. So these are all different kind of scenarios. I know this is very fast, but I want you to get some kind of impression. If you see some of the similar issues, you can always come back and to do it. All right. So the commander here, once again, you can just use ChatGPT to give you a perfect answer. All right. So that's how you resolve changes. This is very common in practice because normally you work with the team members. You guys are all making the change in parallel. You can never guarantee that your change is always on top of the latest version. But it's often a good practice you can get your code updated all the time. So that way you can avoid doing some of this potential conflict resolving. All right. Next one, you need to know how do you do the branches. Okay, why do we need a branch? So we already got a copy here. Okay, so you make changes and you push it back. You can see the long history. But in practice, most of the company will expect you to push a change if the change is complete. So for example, you're adding this very big feature. You're adding a feature to show all the other competitors' pricing, and that change should take you probably 1 week to finish. You need to add a new database, you need to build a web scraping tool, you need to add a UI stuff. Every day you're making changes. And to be safe, at the end of the workday, you actually want to commit something, you want to push something to the branch, even though it's not a finish, right? So that theoretically nothing wrong, but that's not a best practice because people do not want you to push the change if it's not a finish. And just because it's not safe, you never know what's going to happen. All right. So in that case, if you still want to track and save those changes, what you can do is that you can create a separate branch. Okay, we call it a feature branch. And then because that's not the main master branch, so you just push your change to over there, and that way it's not gonna affect anything about the main master branch. Okay. And then once you're done with your final big change, then you can merge that change back to the main master branch. So that's a better practice. As you can see, as you create a local branch, it basically just create another copy. It just give you another workspace to work on this one. Okay, so this one I think also is very important in today's world because as you use AI to generate a lot of things, it's always safer to do it on the separate branch first until you finish everything, it's all working, then you push it back. Okay, so this is how you do a branch. I'm going to use Bob's. I don't need S anymore. Okay, I'll just use this one here. I'll do git branch. You can see where you are. You have only one branch. I can do git checkout dash branch. I will do a feature branch. I'll call this feature is called uh, food cleanup. All right. And then now I do a git branch. You can see there are two branches right now. I'm actually on this one, which is the load new copy. Okay, so now I go back here. I want to clean up more food. Okay, some of these are duplicates. I don't need this. Okay. And yeah, and then overall, we this month want to promote maybe the Kellogg Ranch restaurant. Okay, I put that at first. So I made some changes. But remember now every change is on this new feature branch. So git status, as you can see, there's a change here. So if I want to go back to the main branch, let's see what happens. Right now, this is a feature branch. I do git checkout main. Okay, I want to go back to the main branch. And now you see, um, wait, this one is supposed to be gone, right? Branch main. Oh, okay. So looks like they can see the change, but then you measure them differently. Okay, let me go back, git check out feature clean up. Okay, so let's say I'm done with this one. Okay, I'll just add things here. Clean up the food. Okay, so get status. Okay. All right, now if I go back, main, yeah. So as you can see, if you look at the history, okay, the main branch only has update coffee. But if I go to, I, I forgot the branch name. If I go to this branch, I do the log. There's one more on top of this because this is only existing in the feature branch. Okay. But then the main branch doesn't have it. So if you think, okay, this is done, I want to merge it back to main. Okay, just like I'm showing here, you're done with the changes and going back to here. What you need to do is that you go back to the main. Okay, you do git merge feature food items. Oh, sorry, clean up item. Oh, never mind. I just bring up the branch again. So git merge. I want to merge this one back here. Okay. Now this one has it. And then what you do is just to push. All right. So that's how you can use the feature branch. I just intentionally try to show this one really quickly because all of this you just have to practice. Okay, I list all the command here. You know which one to use. This is the create a branch. This is the switch branch. This is to merge it. Okay, and then this will be probably the last thing you will need for your project. Along all of this, you often need to undo things because uh, the Git, if you just do a very simple test, normally you don't have any issues. There always has been something that you mess up stuff. Okay, you have to go back to changes, and that's when you really need to undo certain things. So sometimes you're not sure what to do. Always make a copy. Just use a simple approach: copy the folder, make a file, save the file, just in case things are broken. And then Google solution, you ChatGPT to use to find a solution. The good thing is now that it's a lot easier than before. You can use AI to help you to unload those changes. Previously, we have to look at a different kind of sources and check all the command and test it. But undo the changes that's sometimes needed. Undo the commit, undo the push, go back to a certain point. That's all the things you can do. All right. So a lot of resources here. I honestly don't think you really need it anymore. Just use ChatGPT should be fine. But today I want to go through the most important steps, procedures you might need so that when you need help, you know what to ask for AI. Okay, but I really don't think you need to remember any of this command. In fact, these days, some of the tools like cursor, they can just push it for you. So for example, if I say that, you know, color range and yeah, I'll just make some random more changes. Okay. All right, I did some changing. Right here, I just say push to GitHub. That's all I need to do. You literally don't even need to know the command. Okay. So, but what they do is that they just, think about the generative AI, they generate They generate the script, they generate the command, and they just run the command for you. Okay. See, they do git add and then git commit, and then finally they do git push. All right, that's that. So this working with Git, it's getting even easier. All right. But at least you need to know what's going on. Okay. If you see some of the conflict, you know you gotta resolve the conflicts and resolve the changes. All right. So that's why I want to go back to this topic one more time. I want to provide also reference for you. So later on, I will also give assignments on pushing this code changes to build your project pages. But yeah, this one definitely try it. Okay, try the command, um, and as you work with your teammates, just very be careful because sometimes you might accidentally mess up or delete some files. All right. Okay, so that's what I want to stop here. Okay, so I'll send the recordings